Hi, welcome back to Module 3. So as a quick recap, focus, we're going to take a look at the applications of AIoT. Let's take a look at what's the difference between IoT and AIoT again. So in the traditional IoT setting, data is collected, it is stored in the processing, is stored, and later on is processed and analyzed. But before any control is actually sent back into the system, there's actually a human involved. So as human in the loop to actually understand what has been the results of the analysis, and then decide based on the results of the analysis, what's the best course of action to do to control the system. So there's actually human involved in this. Now, we know that actually if the loop has a very large delay between the control that's being exerted and the sensing of the data, that may result in an instability, because a long delay in the control loop typically results in the system being harder to control. In the AIoT cycle, or the artificial intelligence of things, we find AI being used in two particular ways. The first one being that AI is actually using together with the sensors to create smart sensors. So instead of just sending back the raw data for storage, we can actually detect certain conditions earlier. For example, if there's a fire, I do not just need to send back images of fire. I should detect the event that there's a fire and then send back the event information so that I can actually react to it faster. And even better still, if I can actually make the decision close to the sensor itself. So this is one of the places where AI is being introduced. Now, the other big area where AI is actually introduced and actually core to the idea of AIoT is that there's automatic action. So you no longer require a human to understand the results of the analysis of the IoT data, but now I have a model that has the rules that's learned from previous examples of the data, right? So now we have a better understanding of what is meant by a model and a rule that is automatically learned from the data from all our previous few videos in this module. So now I'm able to act automatically because I have built a model that has already learned what is the rules to be applied in order to make a certain predictions of what's the most optimal outcome that I want, right? That model will help me to act automatically. So there's no longer a human in the loop to be able to analyze the data and then provide some sort of control to the system. So your model will take the place of the human to actually exert the control if it detects something is wrong. So you no longer need a human to do that. So what is meant by that? For example, in the case of maybe a preventative maintenance, so the data that you're collecting shows the trend that there is going to be an imminent failure of some sort in the system of one of the components. So in a typical system, you need the human to basically understand the results and then make a decision that, hey, looks like there is a trend towards the failure, and I should actually maybe change some of the parameters so that I would avert that failure from happening. Now, in the AIoT system, the human is not in the loop. So based on the model, the model itself will predict the trend. So the model will predict that, hey, there is going to be an imminent failure, but instead of waiting for a human to actually act, the model will then trigger some sort of control action to be done to reduce or prevent further that failure event from happening. So for example, if it detects that there is a fire going to happen in a particular part of the plant, it will just basically shut down that portion or reduce the operation frequency or temperature that's actually present in that part of the plant, so that the things will be restored back to normal and the failure won't happen, right? If there are very high temperatures, or you just apply a control, actually starting the fire extinguisher or sprinkler, so that it'll put out the fire immediately. So this is actually what is meant by the automated cycle. So what happens is that now the human no longer is in the loop directly. The human is just monitoring all these actions in the background, but the control can be automatically exerted by the AI itself. and it's going to be able to react much faster than humans. So human reaction time is at least 200 milliseconds. The fastest human reaction time means when you see something and then you react to it. For example, you try to avoid being hit by something, it takes you at least 200 seconds to move from the time you actually see the object flying towards you. 200 milliseconds is very long time compared with the 1 millisecond that we find in a 5G network. So AIoT systems, the reaction time is much faster because basically it's not humans that are reacting, but it's actually a machine. Machine has a much higher processing speed. However, the model only takes care of the general cases, right? What has been seen in the past before, the rules have been built in, but there may be something that's different about the situation now than what has been observed before. So this is where AI is not the same as human intelligence. So human can deal with novel situations because we have these concepts about the world. We have common sense, right? We have concepts that we learn about the world that, for example, a horse has 4 legs, and even though we color the horse blue, we still can recognize that the horse is actually blue. But artificial intelligence that we have today is not the same as AGI. It doesn't have any common sense. It doesn't have any contextual information or any idea about the rules that generally apply in the world. Like, for example, things don't just float in the air because there's gravity, and you cannot have something that's just floating in the air without any means of support. A human knows that, but the artificial intelligence that we have today doesn't have this kind of common sense notion built into it. So humans can actually react to novel situations really because it's real intelligence. So we can actually have some concept about how the real world operates to take care of those cases. So AI is very good. It can react very fast, but it's really only suitable for application where there's some sort of norm, and the model can predict or generalize for these normal cases. If you have some very unusual cases or something that's really out of the normal, the AI systems probably cannot act on it on its own. It will need to call for assistance from the real intelligence, which is a human. But you can notice that actually there would be a great deal of savings in terms of manpower, right? Because most of the actions can be done automatically by AI itself and do it very fast. But when something actually unusual happens, then it can actually call upon the real intelligence to sort of help it out to make a correct decision. So humans are out of the main loop, but I think humans must always be there as a standby to take care of those cases that the AI really cannot handle on its own. So let's take a look at some application areas that we can apply this AIoT control process. So first one actually is a lot in the industrial setting. So in the industrial setting, we have a lot of machinery. So industrial equipment, they can break down, they can have a certain lifetime, and their breakdown and deviations from their normal operations cost the company money, right? And also reduce efficiency. So IoT can enable automatic control and real-time monitoring of the equipment. So you have all the various assets that you have in your factory environment. For example, the different machines, the different cutting or soldering or soldering machines, or even assembly machines, or even testing jigs. You can monitor the performance of all of these devices using IoT, right, or AIoT. And there have been many cases where people have actually deployed smart cameras to just monitor the performance of the equipment or the movement of the different equipment or materials within the factory floor itself. Are the factory floor materials being moved to the right place at the right time, or have they actually have some sort of obstruction and actually something is actually not working the way that it should? Right, so you can actually deploy in those, and those exception conditions may be predicted, and then we can actually do some intervention to actually prevent them from escalating to a higher level, and then it then becomes destructive. Right, so we monitor the equipment and assets that we have, so also to sort of just ascertain the health level of all this equipment, whether or not it's likely to break down in the near future, or we need to actually send a repairman to actually check on it and actually fix it before that actually happens. So this is definitely one application area, just monitoring the equipment, prevent and just to check on the health, whether the levels or the behavior of the readings that we see is within what we would normally expect, or something unusual is happening and the values are actually quite abnormal or different. Remember, anomaly detection is a kind of unsupervised learning, and definitely you can use machine learning to learn the normal pattern or the baseline in the equipment without having a human to measure every day and create the baseline himself. This can be automatically learned from the data by a machine learning algorithm. What is considered to be normal? So when it actually goes away from the normal, you can also trigger some actions before it becomes worse. So besides just active monitoring, you can also do some actual control to try to force or move the system towards creating the quality that you want. Right. So for example, if you are in a vegetable farm or in a factory environment and you have a certain quality output, you will rely on sensor readings that everything, all the inputs are what you expect. That means the quality of the input material is what you expect. And the timing of when the material arrives is also being collected. So you, with all these inputs, you can basically predict what is the best timing or time or period of time that you can actually combine the various factors together so that the quality of your output is actually optimized. So imagine that manufacturing setting instead of a farm setting, your output could be the assembly of several different components together. So you need to ensure that all these components actually are arriving at the correct time and also arriving in sufficient quantities, right? So that you will ensure the quality of the end product. Another one, which was already mentioned just now, is just basically monitoring the equipment to determine what is normal, right? So that if they observe something that's very unusual happening, you will actually trigger some corrective actions before the equipment actually starts showing some signs of damage or even completely breakdown. So monitoring it actively instead of just collecting information, you need to monitor to establish what's so-called normal, so that when we observe things like very unusual vibration, of course, in the factory, there will always be vibrations in the moving machinery, right? But if there is actually unusual vibration, not the normal range of vibrations, you need to be able to detect it and maybe inspect it further to see if it's actually going to go into the danger zone, right? So it's not that those things don't happen, it's just that we want to actually detect what's the normal case so that we can actually do something when it actually goes into the unusual or the abnormal case. Now, this is actually for preventative maintenance. So just now we are trying to determine when it is actually moving out from the normal baseline values and going to the abnormal or anomalous range of values. So this is the case that we actually try to predict if a failure is going to happen. So all equipment, if it's especially moving equipment, there will be some wear and tear. So there's always going to be a case that you need to replace something within a certain period of time. Now, how you can guess when to do the repair is the $1 million question. So if you can actually predict when is the timing of a failure, then you can actually prevent yourself from actually overdoing it. For example, repairing or removing some component that is actually not due for failure yet, right? So you're replacing it too early. Of course, you're going to prevent the failure from happening, but you're also going to incur a lot of costs because you're replacing components that are actually not needing repair yet, right? You're just playing too safe. You're doing the repair ahead of time when it's actually not due for repair yet. The other case is even worse, right? You actually ignore the problems in the equipment and wait for it to actually fail. Now that's going to cause a lot of disruption because this piece of equipment that it failed may be actually very critical. So if you don't manage to actually do some maintenance ahead of time to prevent that from happening, that could actually lead to very large losses. Maybe also safety concerns, especially if the part that fails is safety critical. So this is actually an area which AIoT can help a lot, because you know, from what we have learned earlier in this part of the module, uh, AI is very good at predicting trends, right? It can detect a pattern in the data that would elude a human. So earlier on, the example was that there's actually a pattern in the recency, frequency, monetary values that actually helps us to predict whether or not a person will donate blood. If you look at the data as a human, you will actually look at all four columns, for instance, because you don't know that time is actually not really relevant. But if you look at all the data, all four columns, you actually can't tell which of them is actually a better predictor for the output that we're interested in, and the response rate for the blood donation. Same here for many factory environments. There are going to be many variables and many sensors coming from different equipment: temperature, vibration, noise, uh, um, um, different directions for vibration, electrical values, energy being consumed. So many different values that are actually being sensed by the different sensors. Now, which of them are actually more important for predicting when the time that's left before a particular piece of component needs to be replaced? Because what you're interested is actually to try to cut down the time to a certain value, but you don't want to be too large, because then you're actually basically replacing the equipment way or component way ahead of the time that you're actually supposed to replace it. So you want to actually predict the remaining lifetime of a component, so that you will predict, you can actually replace it before failure actually happens, but you do not want it to be too long, because then you're playing too safe and you're making unnecessary repair when actually failure is not due. Of course, the other things that just you wrongly predicted, then of course you would not detect it in time, and actually the equipment failure happens, and as you're going to incur all this additional costs. Okay, so preventative maintenance, big application area for AIoT. Is also an area where predicting trends is definitely something which AI and machine learning can do very well, probably better than humans, because humans just get lost when there's too much data. We are good at spotting overall uh, conditions or context, but we are very bad at the details of spotting those subtle patterns in the data, and you need that to have a accurate prediction for this particular use case. So that was the intelligent factory. So let's move on from the factory into the society as a whole, how we can use artificial intelligence, sensors, and AIoT devices in a smart city. So definitely one of the things in the smart city would be the transport network. So there are traffic lights, okay, which are under control. But most of the traffic lights today are under control only one by one. They are not actually synchronized in many ways, and definitely is also not really adaptive to the current conditions. So in many cities, they may even be just based on the the timing, right? Which time of day it is, to just control the traffic lights accordingly. So the better way to do this is actually we are able to send some information from the cars itself, right? So if the car has the route built in, we know that when the car, based on its speed, will reach a particular place, and we can actually control the sensors as well, so smart cameras to monitor the traffic junction, so that we will actually control the lights according to the actual traffic condition rather than just based on timing or time of day. So that's one aspect, okay, in terms of the control for things like traffic lights and junctions. The other aspect really is to help the driver to get to his destination by providing information on what's the correct estimated time of arrival if he takes a certain route, maybe even advise the driver on a different route if there's an alternative available. Other information like the driver habits, whether the driver is driving safely, whether the Grab driver or the taxi driver or the cab driver is actually driving safely. Things like the tire conditions, the engine conditions, this can be all sent up and collected as sensor information, and then we can basically analyze and give advice to the driver when they should actually replace the brake fluid, right? For example, this brake fluid, we are expecting the driver to monitor it, but if the driver forgets or is not careful, then you might find a case that the brakes are not really in an optimal condition. So this is actually a big area because transport, especially vehicles and cars, traffic, is a big application area, and definitely in the modern car today, there are many sensors inside there. And the data can also be used in a financial setting to actually give incentives for safer driving, so that your car insurance premium is automatically reduced. In terms of the smart city, energy is also another important component. So we can monitor energy consumption, energy production in the grid, so that we can optimally balance the renewable, different sources of energy to give you the right energy mix and deliver power when it's required, and store it away for further use when it's already not required. So optimizing and balancing that and having a stable grid is important. Because power failures do cost countries and cities a lot of money, and also drive away investment, because nobody wants to actually invest further in a city where power failures are very often. And there's two main ways to do it. One is that your control is more intelligent, like in this case, right? Your control is more intelligent. You can balance all the different competing requirements by having more data, having AI in the loop to just provide the control with minimal delay. So it's more stable. The other way really is to throw money at the problem, right? And just have built in a lot of redundancy, right? Instead of building a power plant just enough or twice the amount of capacity of what you actually require, so that you have some buffer, you build 3 times the capacity, right? Your total generation capacity is 3 times the normal demand, so that you cater for peak demands. So that's the other way to do it. Throw money at the problem, but that actually generates a lot of redundancy that's unnecessary, and you're basically wasting a lot of resources. So maybe the better way is really to have AI try to manage resources in a more optimal manner. So this is actually another area. So yet another area is actually in the transportation, which I mentioned before just now, just controlling the traffic junctions, the road network, the reroutes in the network. So maybe instead of always having 2 lanes, in some periods of the time in the day, some roads can actually be 1 lane, because that's actually the most optimal traffic flow. This has actually been tried out in some countries where there have been, it's not always the fixed lane. So some lanes are variable. Some times of day, based on demand, based on the traffic flow pattern, they will actually optimize the number of lanes in in different directions. Lastly, most cities have tourists. Okay, there will be a time when the tourists will return after the COVID pandemic. But one of the ways is just to make your services for your city much more tourist friendly, so tourists can find the services of interest to them, like rest stops, like toilets, restrooms, and information booths, okay, of attractions, very easily using sensor information. You can just tell them where's the nearest point, where's what maybe they should be aware of. For example, if you are in an earthquake zone, maybe there's some sensor to tell you that there's going to be danger, and then you should actually take shelter in a particular place. If you are new to the city, you may not be aware, and this is some of the other areas that you can use the sensor information to assist the user. Right, so next one thing I'm going to talk about is applications that's not at such a large scale where it's an entire city or a whole factory, but something that is more personal. In our own homes, we can often have a lot of smart, and actually we have been using some of this already. And some of these devices are already being deployed in homes around the world. So the first one will be just all the smart appliances that we have, right? So it could be air conditioning that is able to sense the presence of people in the household is actually automatically turned off when there's no activity, or turned to a very low energy state when there's no activity. Therefore, it doesn't need to keep the the room at a low temperature, or the airflow can be directed to where it detects there's actually a person. Instead of just trying to cool down the entire room, it makes more sense to try to cool down where there's actually a warm body or human actually located, right? So smart, many of our appliance devices are getting smarter, but actually there's still a long way to go before you can truly see a very smart home environment. Lights control as well. Instead of having to have a light switch, you can probably have other sensors that can be voice activated, more AI enabled, so that the light does not require you to actually turn on with just a light switch, but you can actually just ask it to turn on. Same for other equipment like TV, speakers, etc. You can just control this with a voice input rather than just using your switch. And because they are intelligent, they can also coordinate the action. For example, turning off the lights will also turn off the TV, because if the lights are off, actually more likely than not, you are also not requiring the TV. And especially if you confirm that by having the person detector, and if there's no person in the room, then there's no point that the light is actually on. So these are some of the applications, the home appliances like refrigerators. Our fridge today is definitely much smarter than what it was in former times. But imagine if the refrigerator has some AI control in it, it can tell you when the temperature is not optimal based on the kind of food that's currently stored in it, whether or not certain things need to be replenished in the fridge because it is actually very low, and actually is something that you often use. It detects the pattern of your usage. Maybe you always have like 5 eggs in your refrigerator, and then when it detects that actually you have run down to only 1 egg, or it will actually remind you that, hey, this it's just that equipment monitoring, right? So in this case, you just monitor the things that's in the fridge, and if it actually deviates from the normal pattern, it just gives you a warning and maybe reminds you that you should buy eggs or buy milk uh, to replenish your refrigerator. For your home appliance, we often have to set the temperature ourselves for different cooking styles. Imagine you have like a home appliance that you can talk to, and you say, I want to fry a fish, or I want to cook a chicken, and it will automatically set the temperature and cooking cycle based on your requirement for actually cooking the dish, right? Not just you, human being, having to control everything one by one, but you can just basically give it a overall intent that you have as a voice command, and it actually gives you the result that you want automatically. Think about it. It will make life a lot more convenient. And then AI speakers like your Amazon Echo, Google Home, now they're already starting to emerge in many homes. So these things can be, of course, combined with the other smart appliances that you have, so that they will actually be able to work together, right? So you can ask the Google's Home to actually play back a menu for you on how to cook a particular dish, and at the same time, the Google Home device will also send a command to your cooker, the cooktop, to actually reset the settings for the particular dish that you want. And it can be applied to lighting and refrigerators and everything else that you will actually find in the kitchen as well. In the other environment, which is actually a personal environment, of course, there are actually a lot of applications for IoT at a personal level. So you can see this the guy jogging here. So actually, one of the big sensors is actually the wearable devices, right? A smartwatch or a Fitbit that you can watch as to monitor your jogging, your health, whether you're living a healthy lifestyle, whether you have adequate exercise, whether you are having a regular heartbeat. In case there's something wrong, you can actually seek medical attention earlier instead of waiting for something to happen. So wearables, definitely one of the application areas for AIoT. In fact, the way the Fitbit works, actually, the device itself is actually fairly simple. It's just a motion sensor, right? Sensing your direction of motion in X, Y, Z axis, and also rotation. What actually makes it very intelligent, can tell whether you're jogging, running, or walking, or just standing, is actually the AI behind it, because actually there are models that have been trained using lots and lots of data from different motion sensors. So based on the data that's been collected, they're able to predict using the values what exactly is the activity state that you're in. Are you actually standing, sitting, or jogging, or you are walking? So it's actually driven by data. It's not just the activity state is not driven by something in the Fitbit itself. It's just collecting information about your movement, but it can't tell what you are doing. It's only the models that have been trained from all this data that's been collected over a long period of time that they're able to do this. Now it applies to humans, and today you actually have a Fitbit for your pets as well, right? You can actually attach a Fitbit to your dog. Uh, just think about it, the movement of a dog and the movement of a human is quite different. So actually you need to build a different model if you want to apply your Fitbit to a dog accurately. So taking a human Fitbit and just putting it on a dog may not give you the results that you want. But if you have a special pet Fitbit device, it should work, right? Because they have actually trained the model to account for the movement of the dog or pet itself. I guess for snakes and other pets, it will be even quite different. So besides the fitness, of course, AIoT devices can be used in the medical context. So just monitoring your health, especially for we have many cities that aging populations. So monitoring the health of the elderly to make sure that they are in good health or they do not need further assistance or medical attention. Right, so this is one thing, or they have not fallen or injured themselves. So the other one is basically the doctor can actually attend to you, not face to face, but maybe via teleconferencing. But they do need some sensing of your conditions. So normally, if you visit a doctor, they could take your blood temperature or your pulse. But if they are at a remote location, they are not going to be able to do that. So they need to have some way of actually monitoring or getting these readings like your pulse and your blood pressure, or maybe even glucose level from remote, right? So those things will only be possible if you have some sort of AIoT sensor, right? Something that can measure blood pressure, glucose level, oxygen level, and your pulse, okay, in an accurate manner. We know that many smartwatch devices already do this, but it is still not that prevalent that everyone can basically use this to monitor their health. So we will move towards a case where this becomes far more pervasive, and we do not need to visit the hospital as often or visit the doctor as often face to face, and we can do a lot of things just via remote monitoring together with all these AIoT sensors. Will just help the doctor be the assistant for the doctor to gather the information that they need so they can make a diagnosis. And AI can also be used to help the diagnosis, because getting the different symptom information together and piecing together what these symptoms actually mean takes a lot of experience. There's definitely some pattern involved, but AI is very good at detecting patterns, right? So, and it can actually detect more subtle ones that maybe escape the attention of the doctor, especially for the diseases that are somewhat more unusual, and the doctor may not have actually encountered these diseases before. So they would normally think that it's a normal disease and they may actually escape attention. Right, so diagnosis, collecting sensor data, and then just monitoring the health. These are some of the application areas for AIoT. And with that, we come to the end of this series of videos. So there are many application areas. I think it's just really limited by the imagination of humans. So AI is very good at spotting trends, spotting the pattern from the data itself. And by being able to spot the pattern, we can actually enable many applications that were not possible before. It's simply because there are not enough experts around, or there are not enough people who can actually tell you what to do from just the data, because the patterns are too subtle for humans to detect, or it takes too long for us to detect it. So thank you again for your attention, and I will see you in the next series of videos.